All right, hello. This is Mr. Dermott again, coming to you with a quick test review. We have our first test of the year tomorrow, and I want to make sure that our kids are ready to roll with it. So I'm going to give you some problems to think about that are kind of the flavor of what is to come on this test. So I'm going to try to go kind of in order from stuff that we've done in the past, earlier in this year up to where we are currently. So one flavor of question that you're going to see on the test is questions where you have a original figure, in this case it's quadrilateral A, B, C, D, being going through a series of one or more transformations to get to a new figure, A prime, B prime, C prime, D prime. Now on the test, you're going to be answering this multiple choice. So there will be, sentences that are describing those transformations. So it would say like, oh, is it translated 4 left and then reflected over the x-axis? Is it rotated 180 degrees around the y-axis, around the origin, and then translated? But it'll be multi-step. For our purposes right now, if you can take this shape and tell me how I get over here in a couple of steps, then you're going to be doing pretty good. So what I would do on this to make this transformation happen is, I'm actually going to grab some patty paper for this. And you'll have access to patty paper on the test if you choose to use it. So I'm just going to trace this guy really quickly. And now that I've traced my shape, you can see that that's laying right over the original. Let's see what I can do to get all of our points. Our A needs to match up with A prime, our B needs to match up with B prime. So a great first place to move, let me see, can I do a rotation around the origin to make this happen? Remember, when I do a rotation around the origin, I use something to kind of hold down that patty paper around the origin, and then I literally rotate it. Okay, all right, so I'm looking there. That gets me in the right direction. What happens if I rotate all the way over here? Nope, look at me, I'm upside down. That's no good. But it looks like if I just do this rotation right here, that gets me pretty close. So I could say that I'm going to rotate 90 degrees around the origin, clockwise around the origin. And then what would be my second move? And then it looks like my second move would be to do a translation. So how can I get D to match up with D down here? It looks like I need to translate to the left, 1, 2, left 2, and then down, 1, 2, 3, 4, 5, 6. So translate to the left 2 and then down 6. And so those are directions that would take me from my original shape of A, B, C, D down to A prime, B prime, C prime, D prime. I just want to make a note that that test may ask for this in a couple of ways. It might say A, B, C, D is taken to A prime, B prime, C prime, D prime. The other way that I've seen this written that's really sneaky is what transformations prove that ABCD is congruent to A prime, B prime, C prime, D prime. And the reason that that's still, both of those questions are asking the same thing, right? This is saying, how do I make ABCD cover up this A prime, B prime, C prime, D prime? This one is saying, how would I prove that these are congruent? Well, the way that I would prove that they are congruent is by taking that shape and again, proving that I'm able to cover it up through rigid transformations. That would prove that it's congruent. So just be mindful that there's a couple of different ways that that question could be asked. And the Patty paper is very helpful for this. Make sure that you're counting accurately on your points as you're going. That's one flavor of question. I know there's a couple of questions that are going to require you to identify transformations that have taken place or execute transformations and tell me ordered pairs. Another type of question that you're going to have when we take this assessment is on our vertical angles, okay? Question might ask, what is the value of angle, DEC? Well, we should know that that DEC, because it is a vertical angle with angle AEC, that those two are going to have the same measures, right? So this is going to be 93 as well. Now, if I know that, I actually can tell you even more about these angle values. I can tell you what the value of that angle, AED, and I can tell you what the value of CEB is as well. I can tell you the value of both of those. And I'm just going to pause and make sure I'm actually recording. And I am. Okay. Got limited time. I had to cover a class today, so did not get to do this during second block. My apologies. So I know that a straight line has 180 degrees. You've got to remember the number 180 for this test because straight line has 180 degrees. We also remember from our notes that the interior angles of a triangle add up to 180 degrees. With it, we're going to apply this straight line value of 180 to figure out this unknown value. If I know that this is 180, all I have to do to get this is to take that 93 that I've already calculated out of it. And I think that gives me 87. So I know that this angle is valued at 87 degrees. And again, I can use my vertical angles. This angle is vertical with this. So I know that that angle is also 87 degrees. All right. So you're definitely going to see that on the test. That's kind of covering what we have been doing for the last now 3 days, working with angles and what we know about them. And I just want to remind you guys that you know that angles are vertical because of transformations. If I have this angle right here, I know that it's a vertical angle. I know it's the same as this other angle because whenever I do a 180 degree rigid rotation, look at that. It covers it up. So I know inherently that that angle is the same as that angle. I could do the same proof on this side. Okay, great. Man, we did so much with triangles, and triangles are going to show up strong on the test. So I want to look at this triangle right here. So what we have here is an original triangle, A, B, C. I drew that in black. And there's a couple of transformations, rigid transformations that have happened. The green triangle, CEB, shows the image after triangle ABC is reflected over this line, CB. We also have another transformation. We have triangle ADB, which is created after a rotation around midpoint M on triangle ABC from line segment AB. So we're given some values. We're given this value at 1.3. We're given this segment value at 2.7. And we're given this angle value at 62 degrees. So the question is, how much do I already know about this shape? What blanks can I fill in? So let me just show you. You can fill in a lot of blanks. So this, again, I'm just coming to my patty paper to prove this. I don't think you need patty paper to solve these. You're welcome to use it during the test. Okay, so let's look at this reflection and see what angles and what sides correspond. I'm going to reflect this over line CB, which means I'm going to flip it over. I'm going to make line CB match up. Okay, there we go. So let's see what angles match up. So here's our 62 degree angle right here, right? This is our 62. Where does that angle line up? Right there. You guys see that? So I know now that this angle right here is also 62 degrees. Okay? Going back to that reflection, I know that right here, this side is 1.3 and this side is 2.7. When I do that reflection, look what I learned. That 1.3 is now this side right here, so I'm going to label that. And if you look, that 2.7 is actually in the same location as where it was, because that's the line of reflection that we're going to execute there. But there's more. There's more that I know about this shape. Check this out. If I take this guy and I rotate him around my midpoint right there, I have my triangle up top right here, right? So look, this is my original 2.7 side, and that corresponds with that. So that corresponds with line segment AD in that image triangle. And then I see that side AC corresponds with side DB. Oh, I should have written my value there. It's 1.3. And then my angle, my 62 degree angle is now up here. It's now angle D. And so if you're a parent and you're kind of mathy, then you actually could probably show how you would get all of these angles and even all of these sides at this point. For our 8th graders right now, we're just using what we know from those reflections. We're not into any Pythagorean theorem or anything. There will be none of that on the test. But just understanding where our corresponding angles are. And it'll say that this triangle is a reflection. It'll say this triangle is the outcome of a rotation around this point. You just have to be able to match up those angles, all right, and tell us what they are. Fabulous! Fabulous. Let's carry on. So we're going to be doing some reflecting and rotating and translating of just plain old single points, okay? So when I look out here, I've got point A. Its coordinates are 1, 2, 3, 4, comma, 1, 2, 3, 4, 5. Okay. And so let's see what we can do. So it says, what happens to our coordinates? Give me the new coordinates after I take this point and I reflect it over the x-axis. So guys, reflections we're struggling on a little bit. when I do a reflection, I need to know what my line of reflection is. I just said there, x-axis. So I'm looking at the x-axis. I'm taking point A and I'm seeing how far away it is from that x-axis. It is 1, 2, 3, 4, 5 units away. It's 5 units up. When I reflect over, I'm going that far the other way. So I'm starting here at the x-axis. 1, 2, 3, 4, 5. So here's my new point 1 after the reflection, okay? And my coordinates there are starting at the origin, 1, 2, 3, 4. So that's positive 4. Starting here from my up and down my y. 1, 2, 3, 4, 5. That's negative 5. If I'm translating 2 left and 3 up, what does that do to that point? Let's see. 2 left, this is easy. 1, 2, 3 up, 1, 2, 3. And I just write my new point. That's a positive 2 for the x value. And then 1, 2, 3, 4, 5, 6, 7. I'm going to double check my count. 1, 2, 3, 4, 5, 6, 7, 8. That's why we double check. Okay. Next thing I'm going to do is I'm going to rotate this guy 270 degrees around clockwise. So if I start here, remember that that's 90 if I'm going clockwise. That's 180. That's 270. Okay? So I'm going to be somewhere up in here whenever I get this. So what I do is I look at my driving directions. So if I start with going straight up, to drive to point A, starting at the origin, I go out, 1, 2, 3, 4, 5, and then I take a right, and I go 1, 2, 3, 4, okay? Well now, if I'm going 270 degrees, originally I was going this way, straight up. Well now, we said 270 degrees, I'm gonna be right here. I'm gonna be going this way out. So I said I went out 5 and then I hung a right and then I went 4 in that direction. So I'm gonna start here. 1, 2, 3, 4, 5. Take a right. And then I'm gonna go 4. 1, 2, 3, 4. And there's my new point for my A prime after a rotation 270 degrees clockwise. Remember that 270 degrees clockwise is the same as 90 degrees counterclockwise. My point now is negative 1, 2, 3, 4, 5, negative 5, comma, 1, 2, 3, 4, negative 5, 4. Fabulous. So being able to execute those transformations just on individual points on a coordinate plane is something that we're going to need to be able to do. We also learned quite a bit about what we can demonstrate given parallel lines based on our understanding of vertical angles. Man, this is like the most powerful thing right here that we're going to cover during this unit, to me. So I'm using my patty paper again just to make a point here. So I've traced that. I'm going to tell y'all that given this one angle, you actually have enough information to populate literally every angle on this page. You have so much information that you can make conclusions about just based on what you know from transformations. So guys, I know you don't see a triangle, but I kind of see a triangle here. Okay? If I take that triangle and I rotate it 180 degrees around that vertex X, I get that right there, which is the same. So again, this angle is a vertical angle with that angle of AXF. So this angle is also 125 because it's a vertical angle. But here's the cool thing, there's so much more that I know because I can do more rigid transformations. They're going to show me that if I do a translation down and to the left, so that I take angle AXF, if I take that angle to angle CZF, look at this. This angle up here is also 125. And this angle down here is also 125 because of vertical angles. And then check this out. If I translate this guy to the right, this angle down here is 125. And this angle up here is 125. And then I translate up and to the left, and look, I've taken it to another location. Look again, it covers it up. This angle here is 125. And this angle here is 125. And y'all, if I know that this part of the angle is 125, then y'all, I know what this angle is. Because I know that my blue arc plus my pink arc together has to equal 180. If I know that this portion of it is 125, all I gotta do is subtract that from 180, and that'll leave me with what, 55, I think? My math is... And y'all, once I have that, it's the same thing, guys. Look, that 55-degree angle is the same as this one. This is also 55. And then, just like I said, that same intersection, every time it happens with these parallel lines, it's the exact same. You know so much about that shape because you know about properties of parallel lines. Fabulous. Okay, so I believe that pretty much covers the general flavor of the questions that are going to be on this first test. There's some practice problems that are posted online that we went over as a class today. That is under today's date in Canvas. I think it's under student test review. I think there's 2 sets of practice problems. Excellent place to look. I think watching this video, trying to recreate this and explain your why is a great way to prep. And of course, looking back over those notes. So that's it. I just want to thank everybody that is watching. I want to thank all of my classes. The math notebooks are looking amazing now. I've seen such a transformation in urgency and effort among all of my classes, and I am so excited to see how y'all kids do on this test. There will be the opportunity for test corrections or retakes. That information will be coming out once we actually know how y'all did on the test. So appreciate your time, and look forward to seeing how y'all do it tomorrow. Have a good night.